We will start with text mining of biomedical literature. And this exercise I will do in R, totally in R and R Studio. So if you want to do with me, you're most welcome. You can do it. Or if you want to watch how we are doing it and then try later, that is also your choice. So what I'm going to do is basically can you all see? Hello?
Yes, sir. Yes,
Yeah.
sir.
Yes, sir.
Okay. Yeah.
Sir.
Thank you. So this is the paper we shall follow for this course. And this is a paper we published a few years ago. This is not the only paper in text mining. There are many papers, and I am sort of following this paper in this particular course. So we use this package called PubMed.miner, which is an R package with text mining algorithms to analyze PubMed abstracts. So you may already be familiar with PubMed. I'm assuming that most of you at least, and you would have attended the R and R Studio sessions also before. So then it will be easy for you to follow. So this is the NCBI database or portal. Some people also say it as portal. And here it is, from here we get all the sources of our biomedical papers, mainly the abstracts. We can also get full text from another database called PubMed Central. So the NCBI has many databases. As you can see here in this pull down menu. And here is where is PubMed. And then there is this PMC, which is called PubMed Central, which has free papers, full papers. So with PubMed Miner, we can use text mining with full papers also and with PubMed also. There is some difference between the two in terms of how they give you the data. Okay. The NCBI has a highly secure system of how you can download and retrieve the data. So that difference is there between PubMed and PMC. So the way we start is that we first decide on a topic and then we proceed. The topic can be of our area of interest, and that topic is usually a disease topic because human disease is one of the topics in which a lot of research is done. So I shall go here and select PubMed, and I shall type the words diabetic retinopathy. Diabetic retinopathy. And here there is a search button. So we click on this search button here. And it is doing some search from its database. and giving us these results, 41,613 results. If any of you are doing it, you can do it in parallel in your own system, and you will enjoy this whole exercise. So here is listed all the papers, and in the first view that comes in this NCBI portal, you can see the title is described here, title, authors, the journal along with year, and the digital object identifier. It is an e-publication. It is also a free article, meaning that its full paper is available in the PubMed Center. And it has a PMID. So every paper has a digital object identifier and it has a PMID in the PubMed database. So this digital object identifier is for the internet, the entire web. But PMID is only recognized in NCBI. It is not valid outside NCBI. Okay. So this is how the data is organized, and a few lines of the beginning of the article is given to give you a feeling that what this article is about. 2-3 lines. Now, our job starts with getting this data. So, the first job is information retrieval, and this has to happen from the PubMed database. So, this is not new to most of you probably, because you would have been aware of this NCBI PubMed database already. But it might be new that how we go about data mining or text mining of this data and what all it can do and how it can increase our view and our understanding of the literature material present in this set of abstracts. So now downloading this needs NCBI tools. So we go here and click on save, and there are two options it shows here. One is all results on this page. So how many results are there? There are 10 results on this page. So if somebody wants to only look at just the beginning part of all results on this page, then they can look at the first 10 publications and decide what they want or what they don't want. Now here there is this display options. How do you want the data to be displayed? So these are all part of NCBI tools. And what they have given option here is the format, which happens to be the summary. Then sort by best match. And then per page 10 records. So we can increase this. We can increase to 20 or 50 or 100. It's in our option. And in this sorting, also some options are given. So the default is best match. to the keyword that we are using, or the most recent, if we want the most recent one, or sort by publication date, or first author, or the journal. So there are many different options are given. We can go by most recent. Click on most recent, and you can see in the background, it ran something in a few seconds, very fast. And you can see that the most recent paper has come in front of us, which is the first paper on diabetic retinopathy, which is a disease of the eyes in people who are having type 2 diabetes, even type 1 diabetes maybe. So basically, people who are having diabetes and for a long time, and if it is not properly controlled, then their eyesight gets affected. So a lot of research is going on how to uh, correct people's vision if it has become affected. So there are some solutions are there for that, medical solutions. And a lot of people want to know that what are the risk factors and how these risks are modified during the process of this disease. And India is becoming the capital of diabetes. Earlier, China was ahead of us. Even USA was ahead. Now India is coming very close. It's a lifestyle type of disorder. There is some genetic factors also involved in it, some environmental, some genetic, and then nowadays people are talking about epigenetic mechanism also that is happens to play a role in this disease. Complicated disease and requires control. So now for us, we have to do some text mining. So how do we start and what do we do? So first is let us save this data. So instead of all results on this page, we go for all results. Now you can see that it mentions here only the first 10,000 citations will be saved in your file. So there is a limit that the NCBI has put for releasing the data in some batches. So what do we do? So the best thing to do is to have a publication date wise cutoff or increase our stringency or filters. So we are already doing text mining, but this text mining is not in R. This text mining is using the NCBI tools itself. So we'll do all that, whatever is available from the NCBI, and then we will go into other steps in the R package. So let's click on advanced here. And now you can see that a new page opens up. It's called the NCBI Search Builder. And here we get so many options. All fields, author, and so on. So I usually go for title or abstract and type this word diabetic retinopathy and click here add. So this is the first filter we have designed now, where in the title or abstract the keyword that we are entering, diabetic retinopathy, it must occur. It must be there somewhere among these two parts in the abstract. Then the second is we also add some keyword here, another filter, which is on the date of publication. So let's say we ask the question, last 5 years. Let's say, for an example, last 5 years. So now we are in 2022. It's not over. So let's go back. It is 2021, 2020, 2019, 2018, and then, hello, everybody
2017.
quiet?
2017.
Yes, sir, we are listening.
2017. Listening okay, but sometimes you can talk also. Okay. So 2017. So we can do from 2017 to present. So let's try that. So this is the year, this is month, and this is day. So 2017, month will be 01 for January, and day will also be 01 for 1st January to present. Let's click here and. So we have now added two conditions. Two conditions. Now we click search. And what do we see? The number of publications have reduced. It has come to 10,133 results. So what we'll do is we'll go for this and we'll save it. It will say that I will give you only first 10,000, doesn't matter. So let's go for that and let's do our work today with the 10,000. If you want the whole thing, then that also can be done. How? By changing the publication date, you give it from different periods, and then we can combine them together later in the R package. So let us save this. We want all results, and it has already given the warning. It's fine for today. And instead of summary, we will ask for abstract, the full abstract. And then we'll say create file. So it says that what do you want to do with it? So let us say save as, and I select the folder, which happens to be Nextgenhelp. And this is the file. So I say save it with today's date, which happens to be 19/09/2022. I hope everybody can see you, and it is saving it as a text file. That's one of the options. There are two options in which from NCBI we can get the data. One is text, another is XML. So XML, later when we get time, I will show you example of XML also. It has to be done a little bit differently, but the text file is very straightforward. So we'll start with that. And it has saved, looks like. So we can go to the R Studio here. And I am in this directory. So it has downloaded 25.6 MB data. Here it has downloaded. and I am already in this directory. So those of you who might have not known or forgotten, click here as set as working directory, and then we are here in this working directory. So now let's see what the paper says. The paper says there are functions called readabs for the text format and XML readabs for the XML format. So let's go for readabs and we name it as DB Retino ABS. ABS is a short form for abstracts, and I typed read ABS and it is showing two functions here. So since the original publication, we had added a new functionality, a new function here. We'll use the new function. And in double quotes, we have to give the file name, that is this file name. So which happens to be abstract. And then I press the tab. Once I press the tab, it is giving me two options. The first one is our today's downloaded file. We go to the end here and give this command. So it will take a little time to read these abstracts. It is already finished. I'm doing this in my laptop. So I'm pretty sure in your laptop also it will work with the same speed. So if I click on packages here, you can see PubMed Miner is here, and I had already, by clicking here, I had installed this package here, or the library. In uh, our language we call it as library, and it is installed here and is available. So once this package is installed, then only the functions which are there in the PubMed.miner package will become available. Otherwise, in R, whatever base packages they have, like this methods, graphics, GR devices, these come in the R as base packages. So when you start R Studio, then these packages will be already loaded by the R Studio and R. So whatever functionalities are there in these packages, they will become available. But PubMed Miner is a added package. It's not in the base package. So if you click like this here, then only the functionalities will become available. So now this is created here, and you can see on the right hand side at the top, this is something I was doing. Sorry, this is the one that has come here. It is about 26.6 MB, more or less roughly matching with the data of the file size, which happens to be 25.6 MB. So it's a large file. According to RStudio, it is a large file. Now, this ABS is an S4 object. So S4 is a new method in R, which is a structured way of capturing data and functions. So if you write functions for an S4 object, that functions will become available. It can run with any of the same type of S4 objects. That's the beauty of the RS4 structure. So let us first look at whether all the data that we had seen in NCBI, whether that has come. So the function that we use is print ABS, and there is a print function in R also. It can also be used, but it will give a very big output. If you use print ABS, it is a little customized function. So you see, you can write, as soon as I type a few letters, I'm already getting the object here. I just have to click. So that's the beauty of R Studio. It's an IDE for R. If you use the regular R, uh, GUI, then it won't be so easy. You require a lot of typing and you might make typing errors also. So the moment I put print ABS, now we can see that the number of abstracts is 10,000, which is what the NCBI had said, that I will give you only 10,000. And it starts with retinal vascular measures from diabetes, retinal screening. And let's go to the NCBI. Retinal vascular measures from diabetes, retinal screening. So it is matching. And so this is the starting paper, starts with and ends with predictors of electrocardiographic abnormalities. So that's the 10,000th abstract that has been downloaded from the NCBI. Sometimes in the text mining terminology, this is also called a corpus, C-O-R-P-U-S, corpus. Now the question is that most often we want to know some things about the literature. What do we want to search for? This is a highly individual taste. Means what is their liking, what do they want to look for? A doctor will look for medical type of research or clinical research. A biologist will look for biology, molecular biology type of papers. A biotechnologist will look for sort of application-oriented biological papers where technologies are used more. So like this, each individual has a different taste and they have a different view of the same corpus. Of the same corpus, they will view it in a different way. So we are doing an initiation way of text mining. Initiation means how to do it. Like NCBI has got a search builder. Here also there is a search function, which is a by which you can build queries within this corpus. Sometimes you can do that from NCBI corpus also. Sometimes it is better to do it through this R corpus. I'll show you how that difference is seen. between the NCBI builder and the package that we are going to use, we are using already. So let us say we want to know some terms. I'm giving you some examples like diagnosis, risk, therapy, like this. Okay. So let's list some words like this and ask this question. So
Excuse
let's
me, sir.
say, yeah,
Sir, in this, you have set it a first directory you have opened.
this directory.
The setting first we have to for paper searching, read command. We have to set a first directory set WD
Yes, I
to
am.
get access to our data into this R package.
I am downloaded the file from NCBI in this directory.
Okay,
Nextgenhelper.
you have downloaded the file and then accessing opening in R Studio first we have to write the command set WD
We
to
have
access
to.
that data in R programming.
Yeah, in R programming you have to write, but here in R Studio you simply click here and it will automatically give the command.
We have to first write this command, then only we can open in our studio
No,
access
no,
of this file.
no, not like that. Whenever R Studio opens, it will open in the home directory here. It will always open in the home directory. It will not open in the directory that we want to work. Why? Because in the
No,
home,
sir. Actually, sir, I'm asking not that thing. Sir, whenever we have to look for a downloaded file to access in to open in this R Studio, so we have to first write the command from where we have to access the give the path over here of
yes,
that file.
yes, yes,
That
yes, yes.
okay, that only. Actually, I was writing that command read XML. My file was not open. Actually, that's why I was not getting
Okay,
that thing. Okay,
okay.
fine, sir. Okay, thank
Uh,
you so much.
don't do XML now. You do the text and check. Okay. XML we'll do it another day.
Okay,
So
sir.
my my terms or my keywords, whatever, ABS. ABS because it is my whatever terms I'm going to give for that, I'm going to get the abstracts. So this is called document classification. So how we classify the documents into different categories. So this is just the beginning step for that. So we can do it in two ways. So let's first do it in this way. So there are two functions, search ABS. When we type, there is a search ABS L and there is a search ABS T. So the search ABS L, you can see the help. It will automatically search the abstracts from the data for the given terms or their combination. And search ABS T will perform a specific search for the given term. So if you want a very specific search, then search ABS T is used. Otherwise, search ABS L can be used. In NCBI, they haven't given that distinction. So you tend to get a lot of extra uh, publications. Sometimes you can work around uh, by the query builder, but here it is in this package, it is very convenient. So search ABS L we click first. And here what we have to do is, first we have to give this R object. That is the primary corpus. So we'll give that here. which happens to be DB retino-ABS. And now here there are functions like this, arguments like this, include. And in include, I can include multiple keywords. So what were our keywords? Diagnosis. Now, diagnosis is written in slightly different ways. Diagnosis, diagnostic, diagnose. Like this, three different forms immediately I can say. And what are common letters within the word up to that is diagnose. Up to S, it will be there in all these three words. Sometimes it is also called stem word. So we'll do this. In search ABS T, we cannot do like this because it is very specific. So it will look for diagnose only. Then it can become a problem. So in search ABS L, we'll do like this. So any of the three words, if it is present, diagnostic, diagnosis, diagnose, then that paper will be captured. Then what more shall I put? Shall I put risk? Hello?
Yes, sir.
Ah, thank you. Then about therapy. Again here multiple words are there. Therapy, therapeutics, therapies. So like that different words are there. So therap is common to all of them. This will cover therapeutics, therapies, and therapy. All the three will be covered in this. Now there is a synonym to this word which will be drug, isn't it? Which is related actually in this. So just to start, let us do only this much and press enter. Now it is searching and it is also combining. So what it did, it has got 2050 abstracts out of 10,000 with the part word diagnose. 2011 were for risk. Then it combined them and you can see that the combined abstracts are 3634. If you add 2050 plus 2111, then the number is 4161 right here. But only 3634 has come. Why? This is because the same paper may have both the keywords. Then it will come 2 times. So the combine ABS function, what it does is it will remove the redundancy and you get 3634 abstracts. Then in the next step, you get 2333 abstracts for therapists, part word. And if we now add 4161 plus 2333, then the number that we should be getting is 6494. But actually, there are only 5311 abstracts, and that is because many abstracts are having multiple keywords in them. So they discuss diagnose, they discuss therapy, they discuss risk also. This is the first thing we can sort of look at it through the computer. We can get to know what this is. Now you may say, how are you so sure? Okay. It is always possible to have this question. So you can always look at some of the abstracts and see what those words are there. So manually we can see some, not all, but some we can see. So the best way to do that is my terms ABS. Now this is also an S4 object of the same class. So all the functions which will run on this original DB Retino ABS will now run on my terms ABS also. That's the beauty of S4 structure in R. So that's why it's very heavily used in bioconductor and many other packages. So the best way to get data from an S4 object is to use the slot operator. It's called the slot operator at. So I press the letter at. In email we have at gmail.com, that at. And immediately you can see there are 3 slots here: journal, abstract, and PMID, just as we saw in the NCBI site. So let's put journal, for example, and say 1:2. So this is a vector. And we can see here that in this entries, the journal has not come, but some other term has come. So this sort of thing happens in the NCBI text form of downloading. Whereas when we use the XML, then it will be more clean. We can look a few more. And you can see that there is in the second, that is in the fourth one, there is this journal information, clinical and experimental ophthalmology. Then the next one is photodiagnosis, photodynamic therapy. So like this, the journal names are coming. Now in the abstract, let us see how that works. This is depending on the text form output that the NCBI has given. So abstract, and the abstract we say is, let us first look at the first abstract, and we can see that this is the first abstract. And here what has happened is, in the abstract itself, the journal name has come. That is why it was not appearing in the journal vector. Sometimes the NCBI output, it comes like this. So it will be there in one place or the other. It should ideally be there in the journal vector, which it will be when we use the XML. So we can see here that this is the full abstract here, which describes the context, and the title here is the awareness of diabetic retinopathy among patients. with type 2 diabetes mellitus in Aba, Saudi Arabia, a survey-based research study. So the context is given here, the aims are given here, the methods and materials are here. It was then they have used some questionnaires and then they have reported the results of the 381 patients they have done in this survey. And finally, they come to this conclusion. The current study demonstrated high levels of awareness regarding the effect of DM, which is diabetes mellitus, on the eye and importance of early eye assessment. Meaning that people who have diabetes, they should have regular eye checkups. And if some damage can be caught early, then that time itself, it is better to take precaution. When it goes into advanced stage, then it's difficult to treat them. But then they also have identified some gap, which is we need to improve the patient's awareness to the value of regular eye checking and standard practices like compliance and so on and so forth. Now we can look at the abstract number 2. Now you see, you might have noticed something, that this abstract title is not the title of the first paper we have seen in NCBI. Okay? The first paper that we have seen is this one, retinal vascular measures from diabetes. So this is there in the original corpus, which happens to be DB retinoABS. Now, once we have used a search in our system for diagnose, risk, and therapy, then the corpus has become different. Within the same bigger corpus, a new corpus has been formed, a sub part of it, a sub part of it. And that is different from the previous one. We have to keep note of what is happening in the computer, just to make sure that we are in the track and we are not going to lose the track. Now let's look at the second abstract, and we can see that here we have this journal information happens to be Frontiers in Immunology, and the title is here, which is Integrated Multiomics Reveals the Activated Retinal Microglia with Intracellular Metabolic Reprogramming contributes to inflammation in STZ-induced early diabetic retinopathy. So this is a mice study, probably. As you can go through in detail, these are the authors, their addresses, and so on. This is how the text form of the NCBI output comes. It's not very organized and clean. It's a mix-up. A lot of many things are there. So the XML version will be much more clean. And we'll see that maybe tomorrow or next day. And we can see here what study they have done, they have made. It's a publication from China. And finally, we can see here that these findings suggest that activated microglia with intracellular metabolic reprogramming in retina may contribute to pro-inflammation in the early DR. DR happens to be diabetic retinopathy. That is given here. You can see here. Here happens to be diabetic retinopathy. So we can get a feel for what type of work is going on. That is how the metabolic system in our body changes and how that leads to different outcomes in the disease. It is important to know that because then we can target appropriately and design new therapies in order to overcome the disease. We want to have a good life, right? And that's basically the approach here. Now, I want to do a small exercise and let us see how the two corpus looks a little different. Or because one is a subcorpus, which is focused on diagnosis, risk, and therapy. And then we have the main corpus. So the best thing to do is to
Excuse me.
look at the, yeah.
So what does corpus means? You are saying something corpus.
Corpus is a terminology
Uh,
used in the text mining.
okay. मतलब terminology, some kind of thing in data text mining. Okay. And hello. Hello.
Am I audible?
Yes,
Yes,
actually your
Hello?
हाँ yes sir actually you have मतलब you was missing that time
Okay.
hello
Yeah.
sir so that is related to text mining terminology
Yes. Yes, yes, yes.
okay okay and sir in our studio we can write on script and console both we can write
Okay. So this left lower quadrant. So this is like four quadrants are there. Cartesian system, let's say. Four squares. So this left bottom square is called the console. You can write scripts here, or if you have written here, like I am clicking in the top quadrant, line number 440, then you can copy and paste it here. So if it is a R file, yeah. If it is
okay
a R file like .r file, then I can click here and click on run. Then it will transfer the command here and it will run. One click only.
excuse me sir sir
Yeah.
so in मतलब in our studio we can write on console and script both we can perform the function as we needed
Yes. Yes.
okay sir
Absolutely. So let us try this. What we had? We had DB retino words. So words means the different terms that are used, but we don't want the common words. So it will filter out the common words and give us certain specific words, scientific words for our scientific work. And as we type word, then we can see here word atomizations. We use that and we give this S4 object here, which is DB retino ABS, and press enter. So it will take a few seconds, maybe sometime. It depends on how big the corpus is. If the corpus is small, then it will do it very fast. So it's directly proportional. It's already done. You can see here. And it has appeared here in this table at the top right corner. So it is a data frame here. And you can click on it. So there are two columns. One is the
Your screen, sir.
sorry?
Your
Screen is missing now. Please
Oh.
share the screen.
Screen is missing.
Okay. Now we are there. So
Yes,
you can see the word diabetic. It is occurring highest with highest frequency. Then there is university. Most of the research is done by university students, so that's why it appears here. Then there is retinopathy. So it is a kind of proof that what we have searched for is coming back to us again. That's what it should be if all things
Excuse
are
me, sir.
okay.
So can you show the screen? Your screen is not visible.
It is visible now.
It is visible now.
It's visible, sir.
Visible? Yeah, sometimes that is it okay?
Yes, sir.
Okay,
Sir.
fine. Right. So then you can see patients. Patients is coming at the top. Then there are some numbers are also coming. It's a little bothersome. So 10 but DR is the diabetic retinopathy as we saw. And like this retinal diabetes, this is DOI, which is the digital object identifier, study, hospital, ophthalmology. So ophthalmology is a very important part of diabetic retinopathy, naturally because it's an eye disease. Information, eye, medicine, medical, and their occurrence frequencies are given. So the more a word occurs in high occurrence frequency, that's how important it is. It is very important. Now let's try to do the next one, which we created another subcorpus using diagnosis, risk, and therapy. So what did we name it? We named it as my terms or something. Right here it is, my terms ABS. So my terms words. Again, the same function, word atomizations. And it is my terms. Already I can see that it is giving me the option. So this is the S4 object I have to enter here and present it. So it's done. So quite fast, huh? Compared to all these things just in laptop. And you can see here my terms words is created. And the top words which were coming were common, are coming common in both cases up to ophthalmology. But now the risk word is coming here. So let's see where the risk word is here in the diabetic retino words. So I can click, I can write here, and you can see that it's coming somewhere here with this frequency 4677. So it is there, but it was, so I'm showing 7 to 16 entries here. So China has come. So up within 22 entries, it was not there. Whereas in my terms words, the risk has come within 20 entries. You follow? So when we searched for risk, then the risk word has come to the top. But in the main corpus, the risk word is somewhere much below. Medicine, ophthalmology, those are the words which are coming in the top. So this way, what we get is something called enrichment. That means in proportion, the word risk is coming. You may think that we had searched for it, so obviously it will come. True, we didn't search for diabetes, we didn't search for retinopathy, we didn't search for ophthalmology, but still they came on top, meaning that they will keep coming on top. So these are sort of constant or invariable words with a scientific meaning or a medical meaning. And then the word risk is not so constant, it's a little more variable in the research of the disease of diabetes. Okay, I'll take 1 minute break and come. Not 1 minute, less than 1 minute, so 30 seconds and come. Okay, so now let's see how we have seen these words and their numbers. Now let's see how we can make a figure which can be like an infographic figure. So one way to do it is we don't filter anything. We simply plot the top 50 words, let's say. So we use this package, word cloud, and you can see the word cloud is already helping us here with the help here in RStudio. It pops up. It wants the words and the frequency. And then we can also modify the scale for its representation. And then we don't order it. We sort of give a random order. And we can also use colors. So let's try this.
Sir, your commands are not getting visible. With what you are writing, it is not visible.
Shall I zoom it a little more?
No. It's not the question of zooming. I think it's not the window where you're writing, it is just showing you this my term word table.
Ah,
It's not showing the window where you are writing actually the commands.
So you just need to scroll down, sir. You see the console? Please
okay.
time it.
From 10 minutes, I am also not able to visible the screen of yours.
Try to scroll down the screen, sir. Rohit, sir?
Sir, it's visible for me.
It's visible for you?
Yes, sir, it's visible. It's visible.
Ah,
Got it. Thank you.
ah,
Thank you, sir.
okay. Shall I begin? Okay.
Sir, yes, yes, sir, yes, sir. Sorry for the
Yeah.
Yes, sir.
disturbance. Yes.
No problem, no problem. Word cloud. And so we are not choosing the words. Let uh, some noise also come just to have a practice. We can choose later if we want to make it a nice one.
Still, I am not able to visible.
Huh?
It's still not visible, your screen.
Some people can see, some people not able to see. If everybody cannot see, then there is some problem at
So
my.
increase the percentage and just scroll down, Arpita.
I have zoomed it. Can you see? Hello?
Yes, sir.
Huh. Okay. So word cloud and then the words, right? So word table is here. That's a data frame. So DB retina words. So let's take that. So in a data frame, dollar works. You might have already been familiar with it. Dollar. Dollar words, but I'll take only 1 to 50. I can't plot everything. I need a very big screen for plotting 1 lakh words. So we'll take the top 50 and let's see if top 50 comes okay. Then again DB Retino words, dollar frequency, corresponding frequency we want. So 1:50. And now I put colors. So the colors, I give it in double quotes. And for colors, there is one site here in the R colors site, R charts, R colors. So I can copy this for you. Let me see if I can come to the chat mode. This WebEx, how does it? I think it will be there in the R history. So there should be no worries, I think. So you can scroll down and you can see here. Actually, this comes in Google search itself. It's very easy to get this rcharts.com colors. And you can give blue color. Then there are many options are there like this: blue, brown, Hollywood, cadet blue, coral, cyan, dark olive green, and so on. Lots of colors are available, fire break, etc., etc. So just to start, let us give these colors: violet, then blue, then cyan. It depends on your taste actually, what colors you like and what colors are very appealing and visible. So like that we can create beautiful graphics. sand. Then there was fire brick, I think. Then green. Then we can have orange. So all these color names have to be given in quotes: orange and red. So not many colors, as many colors as the word number is. So naturally, some colors will be repeated, and it's kind of okay. It depends how good it will look. And can you see now that it has created a figure, and the words are drawn proportionally, but it has also given some warning messages because it could not plot within the area that was available to it. So we will change the scale and manipulate so that we can add this color. Now the advantage here is instead of table, you can see here the figure in one go and have an appreciation for how it's a kind of informative. And one word that comes is macular, which we didn't make note of in the table, and that appears nicely here. And macular is a very important part of eye, and that is coming up in this frequency. Of course, we didn't scroll through all the 50 words anyway. So this type of figure is one way by which we can look at this. Now we want to change the scale. So
Sir, the most frequent word diabetes is missing here.
yeah, that's because it says it couldn't plot some words. So I don't know which words it couldn't plot. So I'm going to change the scale now to 3 and 0.5. So let us see if it improves. Yeah, now can you see the diabetic is starting to appear, but it's still not appearing fully.
So
Yeah.
Because it's a very big word.
Yes, sir.
So let's play around a little bit with the scale some more. And it is a little bit better now. Now the word diabetic has come. And I can now zoom this. Yes. So when I zoom this, the words have come. There is nothing left over now because no warning message came. So looks like all the 50 words are plotted and the word diabetic is also there. Now we can save this like this, save images, copy images. So save images and I go to documents, Nextgen, help, open, and I say figure 1 and I save it. So that's one way to save it. Another way is to click on export here and save as image. And now here it gives this width and height, which can be also, so we can keep maintaining the aspect ratio and we can change this width and height. And we can also export a variety of formats, PNG, JPEG, TIFF, variety of formats. And we can save the figure that way also. So this way you can make publication quality figures using this system. Now let us create the word cloud for the other one. So we use the same command. So we click the up arrow, and all we have to do is to change the object name here. So the object name was, I think, my terms underscore words. So underscore words is already there. So I will change it to my terms. And here also I have to do this correspondingly for the same object, my terms. And let it be the same scale and press enter. So now I can click on zoom, and the word diabetic, surely it is coming same in this. Now you can see this word risk is coming, which was not there in the I mean, it's coming in this form here because the risk word has been used. The word macular is same. It's coming in the diagnosis and therapy corpus also. So some of these parts, some of these words, sorry, they are common and some are different. So this way you can generate the infographics and have a comparison between the two different figures, and then have a feel for how the different terms are getting enriched in the corpus that we make. So I'm going to save this also. And I'm going to save it as figure 2. Save it. Close it. Then go to this folder. And here is figure 1. We can open in varieties of ways. And here is figure 2. And we can also export this as, let's say, a TIFF file. And it opens in the this looks a little bit not in the right way. So we can adjust this here. Okay, it's throwing an error. So now let's click again on export. If and is, let's say, figure 2, or let's say JPEG. Sorry, figure 2A. So save it, and we can so this is opening using the Microsoft Paint. You can open it with Microsoft Paint or something like that, and this is now coming as a much more neat figure. So it depends on how much information we want to place in this figure and how you want to explain this to in your thesis or in your dissertation or in the review, for example, in a review if you want to write it, or in a PPT, like any seminar, or how you want to put it. Now, the most important thing to remember here is that these are words that are plotted in a colorful way in this type of a figure. It is not showing how they are connected. Okay. So it is only showing what are those words which are coming at the top. That can guide you for your future work to see, okay, so these are the top important things that are being studied and reported in the literature. Now, what should I do? Okay, so it can sort of guide you towards what type of investigations one would like to look at by further probing in the literature through this figure. The same figure you generate today and keep it. And after 2 days, the same figure you see again, you will get different ideas. Same figure. And this is how the study gets more and more interesting through this type of computer analysis of text mining. And you can see here that this is now we have crunched. We have crunched the literature into some words of medical or scientific meaning, which is very different view and understanding you get compared to the abstracts when we were reading. So it completely changes the picture using the computer. That's all I wanted to do for today. I can take questions and doubts and comments and your suggestions also.